Welcome to solverfy.
This is the answer to chapter 15, problem number 41 from the Smith Organic Chemistry textbook. And this problem asks us to draw the products of radical chlorination and bromination of each compound. And we're also asked for which compounds is a single constitutional isomer formed for both reactions, and what must be true about the structure of a reactant for both reactions to form a single product. And so we should keep in mind that bromination is going to usually form a single product because it's usually only going to cleave the weakest carbon-hydrogen bond. However, chlorination, radical chlorination, is somewhat stronger of a reaction. And so if there are multiple hydrogens that could be cleaved, we will probably get a mixture of products. And so in regards to this problem, looking at A, there's only one type of hydrogen in this molecule. All of the carbons have two hydrogens, and they're all equivalent. And so chlorination is only going to give us a single product here. And so there it is. And then bromination will also give us the same thing, but with a bromine, obviously. Okay, and so then looking at B, what we see here in B is that there are two types of hydrogens in this molecule. So we can get chlorination at one of the primary carbons, or we can get chlorination at the tertiary carbon. So we'll get a mixture here, whereas the bromine is only going to react at the most easily cleaved carbon-hydrogen bond, which is going to be the tertiary carbon. Okay, so then for C, again, there's only one type of sp3 hybridized carbon here, and so that is where the chlorine will react, and then the same is going to be true for the bromine. Okay, so then in D, once again, there is only one type of carbon-hydrogen bond here that is available for reaction. And so we're only going to get one product for each of these reactions. Okay, and then lastly, looking at E, E is another case where the chlorination can occur at multiple carbons, and so it will occur at multiple carbons. So we can get this product, and we will also get this product. Whereas for the bromine, we're only going to see reaction at the secondary carbon. So the product of bromination will just be this molecule. Okay, and so those are the answers. And then to directly address what else the question asked, for which compounds is a single constitutional isomer formed for both reactions? So that would be A, C, and D. And then what must be true about the structure of a reactant for both reactions to form a single product? And so, again, the answer there would be that there must only be one type of carbon-hydrogen bond available for reaction, because if there is more than one type, the chlorine will react everywhere that it can. And so that's the answer to chapter 15, problem number 41.